Hi, Mr. Wright here, and welcome to this film in which we'll work through this question. Now, this question was posted on the community page by somebody who wanted me to solve it. If you are stumped with a question, then head over to the community page. I'll put a link in the description of this film. Post your question there, and I'll solve it for you. Right, let's have a look at this one. Now, I really like this question because it is easily solved simply by setting out a table. I always tend to use a table like this when I'm solving similar shaped questions, and I would suggest you do the same. In this case, we go from small to medium to large. And these similar shaped questions are generally the same. We're going to be looking at linear measurements, sizes of areas, and sizes of volumes. Now, having set that out, let's fill in what we are told. The first thing we're told is that the volume of vase S is 72.8% more than the volume of vase R. So we know the volume scale factor going from R to S multiplied by 1.728. Because that's how you increase by 72.8%. You multiply by 1 point the increase. Now, next we're told that the height of vase R is h. That's a linear measurement. That's the height of vase R. The height of vase T is 6h. There we go, 6h. Okay, we're told the surface area of vase S is A square centimeters, and the surface area of vase T is K times A. So you can see there I filled in the table with all the information I've been given, and I can see that the area scale factor from S to T is K, and I can also see that the linear scale factor from R to T is 6. Now I'm asked to find, in fact, I'm going to just write that times 6 under here because otherwise it'll get in the way of writing down the linear measurements, the height of S perhaps, which is going to go here, isn't it, if I'm able to find it. So I've been able to fill in quite a lot there from the information in the question, and the question is asking me to find out K, to find out the area scale factor from S to T. Well, what can I find out? Well, I'm told the volume scale factor here from R to S, so I'm going to cube root that to get the linear scale factor from R to S. So on my calculator, I'm simply doing the cube root of 1.728, and that gives me 6 over 5. So I know that the scale factor here is 6 over 5. Now, if the linear scale factor from R to S is 6 over 5, but the scale factor from R to T is 6, then the linear scale factor from S to T must be 5. Because then, if I go from here to here to here, the overall effect will be times in by 6. Multiply by 6 over 5, and then you'd have to multiply by 5. So the overall effect was to multiply by 6. So I've now found the linear scale factor from S to T, and that enables me to find the area scale factor from S to T. It's simply going to be the square of the linear scale factor. So that area scale factor, which is K, is going to be 5 squared. So the answer to this question is that K is 25. The reason I like this question is it's obviously considered to be a grade 9 question. It's the last question on a paper, question 26. But in fact, it's relatively easy to solve if one sets out a table like that. There you are. I hope you found that solution useful. If you are stumped by a question, head over to the community page, leave a post there, and I'll have a look. Thanks for watching. See you in the next film.